Did that start?
It was the first
Okay, all
Saturday.
right, hey guys. All right, I just want to go over one thing. Those watching the podcast. So, a student class pointed out how do we go from one step to the next. I multiplied everything by 2 just to simplify it. So if I multiply y squared divided by 2, I get y squared. Y times 2 is 2y, and then 2 times negative cosine x would give us negative 2 cosine x plus c. I would probably get rid of the fractions. Just multiply by these common denominator, in this case 2. Get rid of them.
You don't have to multiply c by 2? C doesn't get affected by anything?
No.
It's a constant?
Because we don't know what the constant is.
Well, it's a placeholder, I get it.
Yeah. All right, so here's the next one, a little bit more complicated. We have 1 over x squared plus x dy dx equals y to the negative 2. In this case, I did change that to 1 over y squared. Makes sense, because then I can just multiply both sides by y squared, because I need it with the dy's. And the dy's got to stay there. I cannot move dy. It's already in a numerator. What I can do is move dx. All right, so now I just multiply both sides by y squared, right? So if I multiply this side by y squared, I end up with 1, and multiply this side by y squared, and then we've got y squared over x squared plus x dy dx equals 1. Okay. Now we can multiply both sides by the x squared plus x. So we got y squared dy dx equals x squared plus x. Okay, so notice that now they both switch sides. And now I need the dx with my x's. So just multiply both sides by dx. So now we can take the integral. We've got y squared dy equals the integral of x squared plus x dx. Really, I should have parentheses around this because it's everything in there is being integrated with respect to x. So now I have y cubed divided by 3 equals x cubed divided by 3 plus x squared divided by 2 plus c. And now I'm trying to solve this equation here for y. So we can multiply everything by 3. If I multiply everything by 3, I've got y cubed equals x cubed plus 3 halves x squared plus c. Now, because this is an odd exponent, I can take the square root. The cube root. If it were an even exponent, I'd get 2 solutions, so it wouldn't really do me much. Cube root of both sides, and I'll be able to isolate y. So now I take the cube root of y cubed, it gives me y, and I've got the cube root of x cubed plus 3 halves x squared plus c. The c is under the cube root now. Okay, and so regardless of what c is, even if it's 0, this will be the equation that satisfies this differential up here. Any questions on this one?
How come, is it because you on the bottom left, the y over, or y third divided by 3, so is it only because it's x squared divided by 2 that you, or is it x squared that you divided it by 2? Or
No, that's what you get when you take the antiderivative.
Yeah.
oh,
Because the
We're-
antiderivative of x would be...
We're integrating at that
by
point.
2.
So here we're integrating, so the exponent increases by 1 and we divide by the same amount. So that'd be the power rule.
If you were to take the integral of that, does the c then become xc? Or cx, and then plus c again? If you were to take the integral of a function with a c in it, what would you get? What would happen to the c?
If we integrate then it would be a cx, yes.
Oh, cool.
okay. Well, then now I'm confused on how you got 3 over 2 x squared.
We divided everything by 3.
And
Oh, so you multiplied.
Or excuse me, multiplied everything by 3, yes.
So
Yeah.
after you, the initial divides and multiplies.
Yes, because we were trying to solve for y. So we were trying to find the equation that satisfies this differential. Now, it doesn't mean that if I take the derivative, it will look exactly like this, right? Because it might look a little bit different,
It'd be some
right?
form of it.
Yeah, but it is some form of this. It could be turned into that.
Well, then what does dividing it do if it's still...
You isolate the y, so it's y cubed.
On this one, this is the power rule. So when I use the power rule, when I'm integrating using the power rule, I increase the exponent by 1 and I divide by the same amount. Because this If I differentiate it, has y squared as the derivative, right? Because the 3 would move in front, those would cancel, and the exponent would decrease by 1.
Okay. I know it's just a weird. So, okay.
It's like the same thing.
And so here we have dy dx equals y squared times x cubed plus x squared plus 1. You just want to get the dy's and dx's together. So divide both sides by y squared. Now I've got 1 over y squared here. Multiply both sides by dx. And now we can just integrate. So we have y to the negative 2 dy equals the integral of x cubed plus x squared plus 1 dx. And so the exponent will increase by 1. We've got y to the negative 1 divided by negative 1 equals x to the 4th divided by 4 plus x cubed divided by 3 plus x plus our constant. And now this is easy to isolate. The easiest thing to do is rewrite as a fraction. That's what this thing is trying to say. It's not that clear. The board, I guess, wasn't being like it's much better, right? I couldn't see it as I was writing it. So we want to rewrite as one fraction here. So this, rather than having 4 separate terms, we can rewrite it as one fraction. The first thing I'm going to do, though, is I need to make this a y, because we're trying to solve for y. Not 1 over y, but y. So if you move, notice I put the terms on the opposite sides, or I could have divided everybody by negative 1 if you like. Dividing by negative 1 will make everybody the opposite. So now the x to the 4th is negative, the x cubed is negative. The x has a negative that you can barely see. There you go. And then the c doesn't matter what it is. And now the y is positive. And then I don't really want 1 over y. I want y. So if I raise both sides to the negative 1 power, those will cancel here. So now I've got y. And now I've made this all raised to the negative 1 power. So now if all of this is to the negative 1 power, then it'll move into the denominator. So that's why I want to rewrite it as one fraction. So my common denominator here is 12. So I could change negative x to the 4th over 4 to negative 3x to the 4th divided by 12. And I could change negative x cubed divided by 3 to negative 4x cubed over 12 and negative 12x over 12. And then the c doesn't really matter. C over 12. And then now I have it solved for y. So the family of functions, the general solution for my differential equation here is 12 over negative 3x to the 4th minus 4x cubed plus 12x plus c. So really, it's just really a lot of algebraic manipulation, no matter, so long as they're separable. So long as I can multiply and divide to move x's and y's, then after that it's just some algebra.
Is this a slope field lesson too?
Mm-hmm. Yeah, this will feed into slope fields because they're related.
Sorry, how did you get 12 again?
It's my common denominator, right?
Oh,
So
okay.
yeah,
Oh, so then you okay, so you multiply those to get, okay. Got it.
yeah.
Yeah.
Good job, Lola. That wasn't sarcasm.
You're a good man, Charlie Brown. Were you really?
So here we have another one. So we have, in this one, we've got variables trapped in e's and stuff. All right, so here we have the square root of x. We'll isolate the x terms on one side, the y terms on the other side. We'll move dy with the y's and dx with the x's. So first of all, we probably should multiply. Actually, first thing I did was I changed it to x to the 1/2 because it's a little easier for me to deal with that. So it looks like I moved the y's first because I've got only one y, but I've got two x's. All right, so what you can do is you can use the product rule. You can rewrite that. Remember, when you multiply like bases raised to a power, you add the exponents.
is true.
Add the exponents.
This looks awful.
Right. Maybe I can squeeze the word exponents in here somewhere. So somebody's wondering what that says. All right, so all I've done here is I need to rewrite. Wish that would show up as I was writing. I lose track of what I've written. Oops, where's my pen? Oh, thank you. So all I've done is I've just changed. I don't know what I just hit, but not now. The last thing I want to do is update this computer. The last update almost killed it. All right, so all I've done here is I've just rewritten that e to the 5y plus the square root of x as a product. Because if I were multiplying e to the 5y and e to the square root of x, I'd add the exponents. And I want to split these up so that I can have x's together and y's together. So I've e to the 5y times e to the x. I'm going to leave that one there, but I need to move the e to the 5y. All right, so I did move the dx, it looks like, in my next line. The order you do some of these things in really doesn't matter. Okay, it doesn't matter if I move the y terms first or I move the dx first, so long as, in the end, the y's are on one side, the x's are on the other side, and you don't do anything you're not allowed to do. All right, so looks like I multiplied both sides by dx because the x's are going to end up here on the right-hand side. Then I divided both sides by e to the 5y. The only thing I need to do now is to get everybody together is divide both sides by x to the 1/2. So now, after I've multiplied and divided, to move the y terms to one side and the x terms to the other, we've got e to the negative 5y, because it was in the denominator. I don't really want it in the denominator. I think I'd rather just have it be a negative exponent while I'm trying to simplify. Dy equals x to the negative 1/2 e to the x to the 1/2 dx. Questions on just this portion of this problem? Yeah.
So there's another portion to it?
There's another portion because we haven't integrated yet. All we've done is we've multiplied and divided and split in written terms so that we could get the x's on one side and the y's on the other.
Okay, so
Negative 1/5 e to the negative 5y.
Okay, if I
oh, I just saw. I had so you
Sure.
moved the e5y on top and made it negative.
yes,
But then what did you bring down? You brought the x.
I divided both sides by x to the 1/2.
Oh, divide. Okay.
Yeah,
divide.
so that's x to the negative
Okay,
1/2.
so that's just-
Yeah, that's just x to the negative 1/2. I was running out of space here, so I didn't have room to write so I just moved that x to the 1/2 here and just made it x to the negative 1/2.
So what happens when you divide e to the x1/2 by x1/2? Does that turn into?
And there's nothing. Yeah, I have to have two terms.
Oh, you just out. Okay.
Yeah.
Gotcha.
Yeah, they don't simplify at all. The bases aren't alike at all. All right, so now we're integrating both sides here. And we have a u to u substitution. Why did all my things moved over a little bit? I know I moved this page around a little bit. The ordering and stuff. What the heck?
If I ever house sit for someone, I'm gonna throw them off by moving everything 2 inches to the left.
I got a bunch of u's here. Well, we'll figure out where all these random u's go. Maybe I've got two of things. Now that goes together. I've got a du. Here's another random u. Let's put all the random u's together. There's a random u. We'll figure out who's missing a u. All right, so we're going to let u equal x to the 1/2. And du equals, so that thing's a w. That's why. All right. I'm going to rewrite this a little nicer because I'm tired of moving around the little u's and things. All right, so I did I did a u and a dw, because w looks less like a u than a v does. Because I have to do two u substitutions here. So my u, I looked over this side and did this one first, and then I looked at this side. So u is x to the 1/2. Du is, we take the derivative. So the derivative of x to the 1/2 is going to be 1/2 x to the negative 1/2 dx. So notice that
Every single 1/2.
this is all right there with the move. Here we go. So this is my du, and then this is my, well, just the exponent part there is my u. Okay? And I am missing the 1/2 here, so multiply both sides by 2, and I've got 2 du equals x to the 1/2 dx. Right? Yeah.
So how did we, I'm sorry for my ignorance, but how did we get the square root of the x to turn into e to the x?
Because when you multiply like bases raised to a power, you add the exponents. So e to the 5y plus square root of x is the same as e to the 5y times e to the square root of x.
Oh, okay,
Yeah.
I see.
Right, so now we'll just integrate, we'll rewrite this side and then we'll talk about the e's. So on this side, I've got 2e to the u du. So after we use a substitution, that's a lot nicer and cleaner. And then I've got another u to u substitution, a little one. So w will be negative 5y. So dw will be a negative 5 dy. And I don't have a negative 5 over here. So we'll divide both sides by negative 5. So negative 1/5 dw is dy. All right, so now we'll have a negative 1/5. And we'll have e to the w dw equals. Okay? So we've just done two different substitutions. I use two different letters, and I usually use u and I use w as my second one if I needed to substitute again. Okay, so now we can just integrate this. All right, so now we'll have negative 1/5. This is just going to be e to the w equals 2e to the u. Right? All right, so now all we have to do is first we've got to substitute back, and then we'll finish solving. So we have negative 1/5 e to the negative 5 w. Yeah. 5y, excuse me, not 5y, not w, y.
Close enough.
Oh, and I'll put the plus c over here with this one. All right, so we have negative 1/5 e to the y equals 2e to the x to the 1/2 power, and then plus c. There's no way I'm going to be able to solve for either y or x in this problem here. So, because they're both they're both exponents. So when you can't solve for x and you can't solve for y, solve for c instead. So now all I have to do is move the terms over. What I chose to do is figured, hey, let's get rid of that one negative there instead of making everybody negative. So, yeah.
If you put 62 in the notes, like on here,
Uh,
negative 1/5 e
maybe you can't read my writing.
plus 60. I don't know what it says. But there's an extra
Where are
point.
you looking?
Oh, maybe it's just a random U that went flying around. So
What the heck?
we'll move the C over, right? So this, everybody would be the opposite sign, right? So instead of having, so C doesn't have to be negative at all, right? C is just C. All right, because maybe that's a negative number. Maybe that's a positive number. I don't know. All right, so, but we're solving for C, which means let's just add, C can come over here and we'll add 1/5 e to the y to both sides. So we have now, and I'm going to put the x term first, 2e x to the 1/2 plus 1/5 e to the y. Okay, so that's what we get when we solve for C, which I have on the step below. All right, so this would be the differential equation that satisfies, this would be the equation that satisfies our differential equation. So since it's impossible to solve the equation in terms of x or y, solve for C instead.
Miss, so it wouldn't be a negative c?
No, because what if it's a -5? Then it'd be positive. We don't know what C is. There's no such thing as having C be a negative. C stands for constant. It doesn't have a sign. It doesn't have a magnitude. It could be 0 for all we know. It's a placeholder to show that if there's a possibility, there's a constant there.
So
Because once we take the derivative of a constant, it's gone anyway. So there's no way to recover what the constant may have been.
So if we want to make those two numbers positive or whatever, we multiply just those numbers by
No, just
negative, not the constant?
we'll just add 1/5 e to the y to both sides. He was the only negative term to begin with. If I move him over with the x, which is what I would have done anyway because it looks a little nicer.
But then you would subtract C. and
But
then-
C doesn't have a sign.
So then it would.
C is a constant. It could be positive, it could be negative, it could be anything. So negative C has no meaning.
Okay.
Yeah, so it doesn't carry a sign with them. That's why there's always plus C.
Cool.
It is just a constant. So that means that our constant value, and that constant value could be 0. So whatever constant whatever value this is, the equation that satisfies that differential is this one here. Because what matters is the rest of this equation. The C is because we know there could be a constant. And it is the only term we can actually isolate. The other ones are trapped being exponents. And taking natural log won't help us very much in this case because they're both E. All right, so here we got another one. So we want to isolate the x terms on one side, isolate the y terms on the other. All right, so this one's actually a pretty straightforward one. We'll multiply both sides by y. We got y dy times y over dy dx. Y dy dx equals x. Multiply both sides by dx. We've got y dy equals x dx. And then integrate both sides. And I don't know what happened to the integral sign over here. When we integrate, we get y squared divided by 2 equals x squared divided by 2 plus c. This is another one where it's impossible to solve for x or y, so just solve for c instead. All right, so I just subtracted. And if you don't like the ordering on that, you can switch them. As long as these signs are opposite. What's that?
So why is it impossible for...
Because it's a square. So I have something squared. If I take a square root, there's two solutions, plus or minus. So now I've got two solutions for both of these things. So now you can, if you don't like the 2 in there, okay, you can multiply by 2. All right, so if I multiplied by 2, since they all have 2, and except for the c, who doesn't matter, because he's just some constant, we would have y squared minus x squared equals c. Or if you like better, you can put the c over on this side. C equals, and then have it be y squared minus x squared. Or if you don't like that one either, you can also do c equals x squared minus y squared. Because if you multiply both of those by -1, now their signs change. So any of those is essentially the same equation in different formats. So same equation, different formats. Just in case this is a multiple choice question and yours didn't look, the answer didn't look exactly like yours. Nobody says I can't switch the orderings of terms. Sometimes people like the x squared first, and sometimes they like the first term to be positive. So if I switch the ordering and I multiply by -1, now I do have positive x squared and a negative y squared. As long as those signs are different. Oh, you're fine. People at home can take notes now too. See, we provide you wait time on the podcast and in class. And so here, this one I have typed up. All right, looks a little bit, it's got a lot of stuff going on here. And if you notice, our y squared is kind of trapped in there, but we could get that out of there because we've got 3 things multiplied. So if we divide both sides by 1 plus y squared and multiply both sides by dx, we now have 1 over 1 plus y squared dy equals 2x e to the x squared dx. Now we can integrate. So if we integrate 1 over 1 plus y squared, that's just arctan y. If we integrate the other one, we need a u to u substitution. U is x squared, du would be 2x dx. So the du is going to replace the 2x dx, and u is now the exponent on e. So you integrate e to the u, du, you get e to the u, and we'll just substitute plus c. So notice this on this one, they showed both constants there. It's sort of optional. I mean, technically, you should have the constant each time you integrate and call it C1 and C2 and then just combine them to C. A lot of times that step gets left off, and kind of shorthand, you just kind of know to put the C there. All right, but just so you understand, to mean technically, we're sort of doing it, we're just kind of doing it in our head, not writing it down and putting the C at the end there on the e to the x side. What's that?
I thought we're not allowed to do things in our head ever. You told me that for 3 years.
Yeah, no, you know. So now we've got this one in particular just solved in terms of arctan. You could also solve this in terms of the constant and have c equals arctan y and minus e to the x squared. But it might be that you want it just solved in terms of arctan y. Maybe you're interested in arctan. Maybe that's the one you're interested in.
Why would we be interested in that?
Because it gives you an angle measure.
Wait,
So maybe you're working with angles, yeah.
Are you gonna start a new one? Start like 26.
Yeah. All right. So we're going to stop this one and we'll start a new one. Bye.